In today's episode, we build a Raspberry Pi Pico RetroGaming console, and we code classic games in MicroPython. The Raspberry Pi Pico is great for many DIY projects. The Pico makes programming in Python fun and simple. Before you can start to program Pico with MicroPython, you will need to install Thonny on your computer. Start Thonny and select the MicroPython Raspberry Pi Pico interpreter. Plug in your Pico while holding the boot cell button and click Install to install the latest version of the MicroPython firmware on your Raspberry Pi Pico. The onboard LED on the Raspberry Pi Pico is connected to GPIO pin 25. You can blink this on and off interactively. To control hardware, you first import pin from the machine module. You specify that GPIO pin 25 is a digital output. To turn the LED on, set the pin value to 1. You can turn it off again by setting the pin value to 0. Okay, let's start building our RetroGaming console by connecting a display to the Raspberry Pi Pico. Before we can use the display, we must install the SSD1036 library. Open the file in Thonny and save it to the root directory of the Raspberry Pi Pico. We first initialize I2C using pins GP14 and GP15. Then we initialize the OLED display. We can fill the screen with fill. We must call the method show to make the change visible. To clear the screen, we fill it with zeros. To draw pixels, we call the pixel method. The top left corner has coordinates 0, 0, and the bottom right corner has coordinates 127, 63. Let's draw a line from the top left to the bottom right corner. A rectangle at coordinate x equals 32 and y equals 48 with a width of 16 pixels and a height of 4 pixels. We can fill the interior, display some text, make a vertical scrolling, useful for choose them up. And display images. Images are encoded with zeros and ones. A 1 activates a pixel and a 0 deactivates it. To store images in memory, we use a byte array. Each byte contains 8 bits, which can be either 0 or 1. From the byte array, we create a frame buffer object, which provides methods to manipulate images. The blit method draws the image at the specified coordinates. We know enough now to start coding a simple game of Pong. Let's start by drawing the ball. The x and y variables store the coordinates of the ball on the screen. The ball is a square of 4 by 4 pixels. To make the ball move, we write an infinite loop. With each iteration, we add the speeds vx and vy to the coordinates of the ball. Clear the screen and draw the ball at the new coordinates. It's all good, but the ball leaves the screen. We have to bounce the ball when it hits the border. You can also display the paddle at the bottom of the screen. The paddle coordinates on the screen are stored in variable xp and yp. The paddle is a 16 by 4 pixel rectangle. Let's add 2 push buttons so that the player can move the paddle. To read a button state, we create a pin object. In means that the pin is an input, and pull up specifies that when the button is not pressed, we would like the pin to report a value of 1. The value method allows to read the state of the button. When the button is not pressed, the pin reports a value of 1. When we press the button, we connect the pin to the ground, and the pin reports a value of 0. Let's continue to code our Pong game. We would like to use the buttons to move the paddle left and right. In the game loop, we read the button states and change the position of the paddle accordingly. Our simple game of Pong is almost ready. Let's add some sounds. To make sounds, we connect a piezo buzzer. To make a sound, we will generate a fast on-off signal with something called PWM, or pulse width modulation. Specify the desired frequency and the duty cycle. To stop the sound, set the duty cycle to 0. Now that we have a working prototype with a screen, 2 buttons and sound, we can build the complete console with a solderable breadboard, a 3D printed case and 6 buttons.